Welcome to The Explainer. Today, we are going to solve an anatomical mystery, and it's happening right inside your own leg. We're going to break down why the knee, one of the most demanding joints in the entire body, has such a complex design for what seems like a really simple job. So let's just dive right in, because this is a fantastic question. I mean, think about your elbow, right? It has the triceps. One big, powerful muscle does the job of straightening it out. So why didn't evolution just copy and paste that design for the knee? Well, the answer reveals a truly brilliant piece of engineering. When you actually put these two joints side by side, the difference is just massive. Your elbow is basically a simple hinge. It's not carrying your whole body weight around. But your knee? Whoa. It's incredibly complex, it handles these huge loads, and it has to stay stable while we walk, run, and jump. We're talking about a completely different engineering problem, and it needs a much, much smarter solution. So here's how we're going to crack this case. We're going to follow the clues. We'll look at the unique challenge of the kneecap, the weird angle of our leg bones, then the specialized muscles that handle it all, and finally, we'll get to the verdict on this incredibly clever design. All right, so if it's not one single muscle, then who's doing all the work to straighten the knee? Well, let me tell you, it is not a solo act. It's a whole team effort. Meet the vastus. The name literally means vast or huge, which is pretty spot on. This is a team of three powerful muscles. You've got the vastus lateralis on the outside, the vastus medialis on the inside, and the vastus intermedius, which is kind of hidden deep down in the center. These three are the real engine room for your knee. Okay, clue number one. To figure out why we need this whole team, we've got to look at a small, free-floating bone that everyone knows, the patella. Yep, the kneecap. You know, this little bone has a ridiculously hard job. It has to glide perfectly in this very shallow groove on your thigh bone. It's like trying to keep a train on a really shallow track. And it gets super tricky when your leg is almost straight, because that's when it's the most unstable. So it doesn't just slide, it needs to be actively steered. And right there, that's why a single muscle would be a total failure. I mean, imagine it. One muscle pulling straight up would be like flooring the gas pedal in a car with no steering wheel. You'd get all the power, but absolutely zero control. The tiniest wrong move, and that kneecap would just get yanked off track. It would be a complete mechanical disaster. All right, on to our next clue, and this one is literally built into the fundamental alignment of our skeleton. And honestly, it's something you might not even realize about your own body. Here's the thing. Our legs aren't perfectly straight columns. There's a natural outward angle at the knee. The fancy term is physiological valgus, but all it really means is your thigh bone and your shin bone don't form a perfectly straight line. And we're not talking about a tiny angle here. It's about 5 to 7 degrees. Now, this slight knock-knee look is totally normal, but for the muscles trying to pull across that joint, oh man, it creates a huge mechanical challenge. So here's the crucial point. If you had one big muscle pulling straight down the middle of your thigh, its line of pull would be fighting against that natural angle of the leg. It would constantly be trying to pull your kneecap toward the outside of your knee, just a permanent recipe for instability. Okay, so we've got two big problems, right? The kneecap needs steering, and the leg itself is angled. So what's the body's solution? Well, it didn't evolve one generalist muscle. It evolved a team of highly trained specialists. First off, let's just take a moment to appreciate how important these muscles are. The Vasti muscles we just met, they're responsible for a whopping 80% of the force that straightens your knee. They are absolutely the powerhouses of this whole operation. Now this is where the design gets really, really clever. Because of that natural angle in the knee, the vastus lateralis sits on the outside of the angle, while the vastus medialis is on the inside. This positioning is everything, because it gives them two completely different jobs. Let's start with the vastus lateralis, or VL. This is the workhorse. It's the largest of the group, and it pulls pretty much in a straight line with the thigh bone. That makes it incredibly efficient at just one thing: generating raw, powerful force to straighten the leg without wasting energy pulling sideways. This really nails it. The vast majority of the effort from the VL goes directly into power. It's not messing around with fine-tuning or stabilizing. It is all about efficient, powerful extension. It is, by its very design, the most energy-efficient extensor you've got. Meanwhile, you've got its partner, the vastus medialis, or VM. This one is the fine-tuner. Its muscle fibers run at an angle, creating this really crucial inward pull.
It's not designed for raw power, it's designed for control. It's the dynamic steering system, constantly pulling inward to counteract that natural outward angle and keep the kneecap perfectly on track.
And that leads us to the bottom line here. A big piece of the VMO's effort is just to steer and stabilize the kneecap, to keep it tracking in its groove. That's absolutely essential for a healthy knee. But it means the VMO is built for control, not for the raw, unadulterated power of the VL. And that brings us to our final contender, the vastus intermedius, or VI. Now this is the underdog, the hidden muscle buried deep beneath the others. And if you just looked at it on paper, you'd think it would be the perfect knee extensor. I mean, look at it. It's located right down the center of the thigh. Because of that, its line of pull is almost perfectly vertical. From a pure biomechanics point of view, its vector is almost 100% pure extension. There's basically no wasted sideways force at all. Which, of course, leads to the million-dollar question. If its alignment is so perfect, why isn't the vastus intermedius our winner? Why isn't this the quadfather? Well, here's the catch. The VI has a few hidden weaknesses. First, it's just a smaller muscle, plain and simple. It doesn't have the cross-sectional area to produce a ton of force. Second, it has less leverage, a shorter moment arm on the kneecap. And finally, its deep position just doesn't allow it to grow or exert force as well as the muscles on top of it. So the final verdict on our underdog is that while it's mechanically pure, it just doesn't have the muscle to back it up. It's a crucial background player, providing a steady pull, but it simply can't generate the peak power to be the star of the show. So, after looking at all the evidence, the unstable patella, the angled bones, the specialist muscles, what's the final verdict in our little anatomical investigation? Well, the knee perfectly demonstrates this core principle we see all over in biomechanics. The body separates jobs. You have prime movers, like the VL, that are lined up for pure power, and then you have stabilizers, like the VM, that are angled for fine control. It's how you get the best of both worlds, pure strength and precision. And this quote right here just says it all, doesn't it? This complex design isn't just a backup plan. No, it's a necessary system for a joint that has to be stable, efficient, and most importantly, able to survive the massive forces we put through it every single day. But wait, the muscles aren't the only things at play here. There's also this kind of hidden support system, and this is where a pretty common myth pops up. We're talking about something called the patellar retinacula. The easiest way to think of these are as passive guide ropes. They're these fibrous tissues that come off the quad muscles, and they basically act like ligaments to help box in the patella and keep it stable. They don't pull, they just guide. So this leads to a really important clinical question. Since these little guide ropes are connected to the main quad tendon, if that big tendon ruptures, can these guys step up and take over the job of straightening the knee? And the answer is a huge, emphatic no. This is so critical to understand. The retinacula are like ropes, not muscles. They have zero contractile fibers, which means they physically cannot generate force. They can help guide movement that's already happening, but they absolutely cannot create it. If your main quad tendon is gone, you cannot actively extend your knee, period. Okay, so we've solved the mystery of the knee itself. We get it, but the story's not over. To really truly understand how the knee works, we have to zoom out and look at its real teammates. See, your knee muscles don't work in a vacuum. They are part of this much larger system. The real power for a lot of your movement, like standing up or running, starts in your hips with your glutes. Then, your vastus muscles do their job of extending the knee, while your hamstrings act like the brakes and the coordinators, protecting the joint from going too far. And because it's all one big connected system, a weak link in the chain causes problems everywhere else. For example, if your glutes are weak, your body is smart, and it'll find a way to get the job done. It'll just force your vasty muscles to work overtime to compensate. And that, my friends, is a fast track to knee pain. This quote just sums up the whole idea perfectly. It's so simple, but it's incredibly powerful. If you want strong, healthy knees, you have to look higher up the chain. The whole team has to be strong and working together. So I guess that brings us to the final question, and this one's for you. Now that you know your knee isn't working alone, that it's part of this big interconnected team, are you actually training all of its teammates? Or are you just leaving your knee to fend for itself? It's definitely something to think about. Thanks for digging into this with me.